So what controls the primary productivity of a community? That's basically the same thing as asking what controls the growth rate of plants. And there are a few different factors that tend to be important. In particular, two factors really control the amount of productivity that you see, at least in terrestrial ecosystems. One of them is water. If you have an ecosystem that is dry, it will not support very fast plant growth, and so you tend to have a low net primary productivity. Similarly, primary productivity stops happening. Production stops happening during cold months. When the temperature drops too low, plants don't grow quickly or they don't grow at all. Particularly when water is locked up in the form of ice, it's like those plants are in a desert. Even if there's lots of snow and ice around them, they can't access that water, and so they have to stop growth entirely. So cold temperatures and a lack of water are what generally limit net primary productivity in terrestrial ecosystems. In aquatic ecosystems, what usually limits growth, in aquatic ecosystems, what usually limits growth is nutrients. There can be some limitations to growth due to missing nutrients on terrestrial ecosystems as well, but generally it's less striking in terrestrial ecosystems than it is in aquatic ecosystems. If you're going to run out of some nutrient on land, it's probably going to be nitrogen, but nitrogen or phosphorus can be limiting in aquatic ecosystems. In our next lecture, we're going to be looking at how sensitive these ecosystems are to nutrients. There's such a thing as nutrient pollution that can really harm an aquatic ecosystem. That's what's shown here. In general, we tend to consider ecosystems as basically being self-contained units. Okay, so the energy that is available in an ecosystem is the energy that is generated in that ecosystem. What happens in a biome stays in that biome, in other words. There are a few exceptions, though, particularly because water carries nutrients and energy-rich chemical compounds off of land areas into water areas. Aquatic ecosystems are usually subsidized with nutrients and energy. The primary productivity of the surrounding land area is what determines the availability of energy in a small stream. In a similar way, you can have islands that are basically deserts with no ability to produce plant matter on their own, and yet they can have a very high energy availability because the ocean around them is full of, it has very rich primary production. This is usually what you see near upwellings, where deep ocean water that's very nutrient rich comes to the surface. You can have a tremendous bloom of life in the ocean in those locations. And this is how you get these vast colonies of seabirds, for example, huge amounts of biomass, not just producer biomass, but consumer biomass, living on these tiny islands that are otherwise desolate. So here's what the globe looks like in terms of primary productivity. If we take a look at this chart over on this side, and I want you to see this because this tells you which the most productive ecosystems are. So the bars here are basically, this is the number of grams of plant matter that are produced for each square meter per year in these different ecosystems. And you can see that there are a few ecosystems that are far and away more productive than the others. Algal beds and coral reefs are the most productive ecosystems on the planet, but they're followed closely by tropical evergreen forests, the rainforest. And these ecosystems are cranking out a tremendous amount of biomass for every square meter. Not far behind them are swamps and streams and tropical deciduous forest. You'll notice one of the things that's true about all of these particular biomes is they are all warm, generally, and they all have abundant amounts of water. As you get to colder climates, things like boreal forests or woodland and shrubland, productivity goes down. As you get to drier areas, things like places like savanna habitat, the primary productivity goes down. What's interesting is that some areas that you might not think of as being really poor in productivity very much are. The open ocean and nearshore ocean areas are very, very nutrient poor. What they're generally lacking in is iron. And so per square meter, places like the open ocean is basically worse than a desert. However, this chart here also shows something that's very important. It shows the percentage of the Earth that is covered by each one of these ecosystems. And that makes a big difference. The open ocean is a miserable place on a per unit or per area basis to live if you are a producer. But so much of the world is open ocean that open ocean contributes more to global productivity than any other ecosystem. Okay, so open ocean is basically an impoverished place if you're a producer, but there's enough of it that it drives. The productivity of the ocean drives the global productivity, the global production of biomass. The only other ecosystem that comes close to being that influential is rainforest. And that's largely because rainforest is so productive on an area basis. Each square meter of rainforest generates so much biomass each year that it contributes a lot to the whole. Strangely, or it may seem strange to you, coral reefs, algal beds, the most productive habitats there are, contribute almost nothing to Earth's net primary productivity because they make up such a small area. If you were to look at a map of primary productivity, in fact, you are looking at a map of primary productivity, this is what you would see. Even though the oceans don't produce much on a square meter basis, there's so much ocean that they end up contributing quite a lot. Here's where you can see the areas of rainforest, and these are the hot spots of biomass production on this planet.